Introducing the BBSSC, also known as the Bare Bones Super Computer. We don't talk about what that second S stands for. Anyway, I'll explain what that name means now. Bare Bones is the simplest Turing-complete programming language, meaning that using it, you can theoretically write any program, although I wouldn't recommend it, because this is how much code it takes to copy a number, and this is how much it takes to multiply one. Quite a lot. So Bare Bones has 5 possible commands. You can clear a variable, increment a variable, decrement a variable, and the final 2 are used to create a loop. As this language is so simple, I thought it would be a good idea to try and use it for my first Minecraft computer. So let's take a look at that now then. I'll start by showing each of the components and have a showcase at the end. The main brains of the computer are here. So we've got an incrementer there and a decrementer there. So that is what adds and subtracts from numbers. And then coming out of these, we've got 2 sets of data lines. So this blue one, that's the input data line to here, and the red one is its output. And these are connected to this lovely bit of purple wool, which is the RAM, or random access memory. So this stores all of the variables within the program, and you can read or write to it whenever you want. Just below these data lines, we have these, which are the memory address input. So these tell you exactly which memory address or variable you want to access. And then just above that, we have the read and write inputs. So if this gets a pulse, the memory will write whatever data is here to the address that is stored here. And similar idea with the read, it will output over on those blue lines the data that's stored in memory at whatever address is here. I didn't make this memory module, I copied it from a video of Matt Batwings, but everything else should be my own. Now let's have a look at the main bulk of the computer. So this is my program storage, or ROM, the read-only memory. So this is where all of the instructions to the program are stored. So this is all written in binary, with a redstone block meaning 1 and no redstone block meaning 0. So the current program I have loaded will multiply 2 times 2. That's a lot of code for a pretty simple task, but it works. And then the green below it, this is, again, like on the RAM, it's to access a specific index of the memory. This cyan circuit here, this is something called the program counter, which basically keeps track of which instruction the program is currently on. So every time after an instruction is done, it will increase by 1 and move on to the next instruction. So once the instruction has been read from the program memory, it will then be sent down all of these lines, and 3 of them will go into the RAM, so those are what tell the program what memory address to use, and then another 3 will go into this little converter here. So these will tell the program which function to use. So one of the lines, which is this one, will tell the program to increment the number in memory. If this one turns on, then it will decrement, and so on and so forth for different for the different functions that the computer can do. This yellow line is the only way that loops are possible. So if this yellow line gets triggered, it will change the value of the program counter to another value. So that will allow it to jump to a different location in memory, and therefore allow the program to start reading code from another place. Finally, this orange circuit here, this is the clock. So this is on a timer, and every time this redstone block gets moved forwards and backwards, it will send a pulse through the circuit, which will then tell the computer to run the next instruction. At the moment it's off, which is indicated by this copper bulb here. Alright, now for the showcase. I'm going to run The first program I want to run is the one I mentioned earlier. The program will multiply 2 times 2. So I'm going to press the button at the bottom. You can see things start to move. And now, because this will take a long time, I'm going to increase the tick rate to about that. That seems good. And hopefully in a minute you'll see the number 8 in binary displayed on this line. And there we go. That is 8 in binary. Just trust. Not 8, 4. I can't multiply 2 by 2. Apparently. It's 4. Now let me quickly, not really, write another program that hopefully will produce the Fibonacci sequence. Right, and there we go, program all written in. And now, when we press this button and speed the game up all the way to its max, because my computer is really, really fast, you should see the Fibonacci sequence output on here. And I will stop it there. So you saw the numbers count up through the Fibonacci sequence. Obviously this programming language is very inefficient, so hopefully I'll be building a better and faster computer soon. Anyway, thank you very much for watching, and I know this video was a little bit different to normal. There will be more building coming soon. And I'll see you next time. Bye!